Good afternoon all, Josh Levine here, and I wanted to give you a quick demonstration on a use case that I've seen come up a number of times during my work with Cortex XSOAR and other SOAR platforms, and that involves tying into network operations use cases. So leveraging the SOAR to not just do security functions, but look at your routing, switching, and any other devices that can be accessed over SSH, and how can you automate remediations or configuration changes on those systems. What I've got up on my screen here is a sample JSON output from a script that is designed to assess the posture and status of a given network device. It looks for settings that are possibly incorrect, missing configurations such as syslog or radius servers, and other things that might need to be remediated to maintain a configuration standardization. So with this output, I'm going to leverage Cortex XSOAR to SSH into a demo router that I've got stood up and perform corrective actions. As you can see in the output here, I've got the device name, which consists of the IP address, the model information, which test was being performed, a description of what the problem is that was found, and whether we're going to do an auto remediation action, request approval for remediation, or leave it as completely manual, something that might be intrusive, causing interruption, or requires manual operator input. For the automated and semi-automated functions, you can see I've got a list of fix commands that need to be defined for each finding. So for the hostname incorrect finding, it reconfigures the hostname to demo1. This is for a demo system, so I use this to make sure I can reset everything back to a known good baseline. Likewise, for the approval required, now this would be something where if you're outside of a maintenance window, but it's minimally impactful, you would put in a step to request approval from either tier 2, tier 3, or some other approval authority. In this case, I'm not doing anything intrusive, but it's just to demonstrate the concept. I'm setting a password for a local administrator account on the router, so that way if TACX goes down or radius goes down, we have a fallback. And then lastly, if I leave my demo system running overnight, this last check is completely manual because obviously I've got to power off the device. Normally this would involve pulling the power cord, but since this is virtual, I have to go shut down the VM. But either way, what I'm going to do is the playbook I'm going to demonstrate for you actually does a handful of things. The first one is going to be the parser. So I'm going to take that raw JSON output produced by my script, and I'm going to send it to XSOAR. And then I'm going to have XSOAR go through and create a JIRA issue for every one of those findings. So you'll have one issue per host per finding. And from there, XSOAR is going to automatically ingest the created incidents from JIRA, so I don't have to manually pull those back. They get created, and then the automatic remediation incidents are actioned automatically. The ones that require approval are sent back to JIRA for approval. And then the manual ones are just there for more of a monitoring status, so you can add notes to the case and so on. So, as you can see, I've got an empty JIRA queue. And what I'm going to do is I'm going to hop over to my terminal. And I'm going to run the create incident script. And this is just debug output I put there just so I know that the script ran. And if I head over to my incidents page, what we'll see here is a number of things happening. So you can see XSOAR's already processed that JSON script, that initial playbook that I talked about. So you can see here that that event did come in, XSOAR did execute it, and it created a JIRA issue for each of the findings, as you can see in the JIRA dashboard here. What's going to happen now with the incident mirroring function of XSOAR, you're going to start to see these incidents pop up as XSOAR refreshes and ingests them. By default, this is done every minute. You can configure that to be as often or as you like, but I'm leaving it at the default of a minute. So refreshing this so it hides the closed incidents. You can see now I've got 3 different incidents for each of the 3 different findings that I have in my sample findings file. I've got the host name being incorrect, I've got a local administrator account missing, and then I've got my demo system being left online. So what I'm going to do, I'm going to hop over to my other terminal. I'm going to make sure terminal monitor is on, so that way we can see the actions being taken by XSOAR. I'm going to go ahead and step into the first playbook, or the first incident, which is going to be an automatic remediation. This doesn't require any approval from an operator. It just takes the action. Again, this would be something or designed for a task that is non-invasive or minimally invasive. But again, also, all of the actions that XSOAR takes are going to get logged into the JIRA ticket. So it's going to have notes in the war room that I'll show you that also get mirrored over to the JIRA issue. So if I look over at the work plan here, you can see that the playbook is running. You can see, thanks to terminal monitor, that my XSOAR user is logged in. It's done some configuration changes, and then it's exited the session. All while the playbook ran in the background and completed. So now if I hit enter, you can see the host name has automatically been changed, so now it's back to my standard host name. If I go over to the JIRA issues board, I'll give this a refresh. You can see the hostname incorrect issue has already been closed, and it added a note as to what has to be done, or what actions were taken. So in this case, it executed configure terminal and then set the hostname to demo01 and then closed the issue or marked it completed. If I go back to my issues board and then back to my incidents page within XSOAR, you can see that that incident was closed out and is no longer visible for me. I'm going to go into the second one, which is a semi-automated process that first seeks approval through the JIRA issue. This addresses one of the core questions I always receive from customers, in that how can I keep humans in the loop when it comes to automation? It's not unusual to ask. In fact, I encourage it because it helps build confidence in the platform. It builds confidence in the workflows that you build and that you construct, and ensures that you're getting consistent and predictable output. So in this case, I'm going to click into the work plan. The work plan is going to start executing, and now it's gone into a loop. It's updated the JIRA case, letting me know that there is actions required. As you can see, this task requires approval before the commands can be executed. It gives me my host name or IP address and the command that it's going to execute. Now, obviously, if you're storing sensitive information in there, you may want to mask that. That can all be configured in the playbook. In this case, it's a demo router. I shut it down every time I'm done with it, so I don't really care. But it's asking me, as a customer, a reply to customer comment, add in approved or disapproved. I'm going to go ahead and approve this change. And this also ensures that you get that log of who gave the approval before the action was taken. Now, as we wait, this polls on a per minute basis as well. But once it gets that approval status, it's going to go through and make the change on the router. And I'll show you that here in just a second as we wait for XSOAR to do that pull. And there it goes. Playbook's executed. XSOAR users logged in. You can see that the admin account was created using the legacy password mode. Again, not tying it into Radius or TACX at the moment. This is designed for local recovery. And then if I do show run and pipe it to the xadmin username, you can see there's the username and password that I just configured. And likewise, if I go back in here, I didn't even have to refresh. It just shows that the following approval required remediation action has been approved and executed. It gives you the device name, type, what actions and commands were taken. And again, that is configurable, so you can be as verbose as you wish to be. I just have it output the entire command, again, because to me it's not sensitive. The system's going to get shut down, so the fact that you see password 123 isn't a huge concern. And then last but not least, the demo system left online overnight. If this VM's running at the close of my workday, I'll get an alert for this. And usually this would be an automated remediation where I can just have it remote into my virtualization system and shut down the server or shut down the box that's running. But for demo purposes, I wanted something to showcase here that you can still have entirely manual actions that can be tracked inside of XSOAR. So both those first two incidents have been closed. I've got the manual incident here. Now, this one doesn't require any action on the part of XSOAR, but it's there for tracking purposes. So you can keep a record of all these findings that came from the output of that script that's run on a daily basis. So in this case, I'm just going to go ahead and mark this one done. I'm just going to say completed. Save that. I'll change it to completed. Give it a sample resolution of done. So that's now complete. And what's going to happen here is this will eventually, once XSOAR mirrors, this incident will be automatically closed. So again, there's bidirectional mirroring. Anything I enter into XSOAR can be mirrored over to Jira and vice versa. But I hope you found this demo useful. Again, this is all about performing things that are outside the scope of security operations and looking further into configuration standardization, automatic remediation, and keeping humans in the loop in the decision process as you build confidence in your automation workflows. I hope this helps, and if there's any content you'd like to see in the future, please let me know. Thanks.